Everyone. Thank you so much for joining us today. We are the Pittsburgh Jug, and I feel like I've said this multiple times in many introductions. It's another Thursday gloomy evening, another one of those days where we have these jug events, which is great because you can actually sit in front of your laptop and just listen to the session now and not have to step out and do anything fun. So with that, anyway, you know how you can find information about your Pittsburgh Java user group. We have the meetup page, which is going to be our primary source of all the future events. The Twitter group is somewhere we are active there. We will be posting. If you're still following us there, then you will see about our upcoming events over there as well. All our recordings are usually up on our YouTube channel. If you haven't already subscribed to it, please subscribe to it so you will get some notifications of when our new videos are up there. We would like to thank our official sponsor, BNY. And with that, I want to hand it off to Victor. Unless, Rinat, you want to say something, or we're good to go.
Just that, yeah, if anyone has any questions, leave them in the chat or ask to unmute, and we'll have this video uploaded probably in a week or so after the event.
Yeah, and one last thing before I hand it off, I just remembered that Istvan has now joined the Pittsburgh Java user group, and he's going to be a familiar face around like hosting these events and finding new speakers and things like that. So thank you, Istvan, for joining us. And with that, Victor, it's all yours.
Thank you very much, Srisha. And thank you, everybody, really, for joining. I think we got lazy after COVID. We used to do these meetings always in person, and now we got used to doing these things virtually.
Yeah.
But I really encourage people to join, personal meetings, real live meetings, because that's how you meet, you network, and you get familiar with people. You go home and you probably talk Java and code, and nobody knows what you're talking about. But this is a great way to interact with people, like-minded people, and everything. Well, that's just my soapbox. So if I died and went to heaven, and they said, "You've been a good boy, Victor. What do you want in heaven?" I would say, "Give me a laptop and an IDE." I love to code. I love to read code. And in my travels, I've seen a lot of funky code and a lot of simple improvements that everybody can make in their code. So that's what I want to talk about today. But first, a little bit about me. I'm a Java champion, along with Srisha and I'm on the Java Community Process Executive Committee representing Bank of New York. I recently published my first book. It's called Real World Java, helping you navigate the Java ecosystem. And when I first learned Java back in the mid-90s, probably before many of you were born, the whole book that you can learn all about Java was about 140 pages long. And now you could read 140 books with 1,000 pages and it wouldn't cover everything. So Gene Boyarsky and I wrote this book to get you started with the most important items in the Java ecosystem, things like your Java IDE. We love IntelliJ, but we also cover Eclipse and others. Things like Git, build tools like Maven and Gradle, logging libraries, and so on and so on. I always wanted to write a book called Hello World that would give you a smidgen of code to get started with everything in the Java ecosystem. Well, this is very much that book. There's a book repo and GitHub that gives you bite-sized chunks of coding samples. So you could just download those, run them along with the book, and really get exposed to everything. I also authored this Pluralsight course about regular expressions, and it's kind of a concise view of everything you need to know about coding for regular expressions in Java. It teaches you about regular expressions themselves, and then how to implement Java matches and patterns and stuff like that. So you could use regular expressions in your daily life. Okay, so getting to the presentation. Some of the things that I've seen in code are just funny and things that could be easily corrected. So does anybody see anything wrong with this code? So one of the things that I see is that it throws exception. And so anything that this method initialize properties file is throwing an exception. And that means anything that calls it has to throw exception. And that's a code smell. This is a little bit better. Well, one reason it's code SML is because it throws exception and it doesn't tell you anything about the specific exception that it's throwing. So if, let's say in this case, we're throwing an IO exception. And so this is a little bit better because it gives you a little bit more information about the exception that it's throwing, but it's still not perfect. The rule is that if you can handle an exception, handle it. If you can't, just throw it as a runtime exception and just like give up. In this case, we're initializing property files for this application, and if we can't initialize our property files because we can't read them, then there's probably no point in throwing any exception. Let's just get out gracefully. And so what I like to recommend is create a runtime exception subclass. It's a runtime exception, so you don't have to actually declare that it's throwing it. Give it a specific name for your application. So in this case, we're calling it framework exception. You could call it anything you want. And throw it as soon as you can, as soon as you know that it can't be handled. There's nothing you could do, just throw that runtime exception. Now, so the rule of thumb is throw the exception at the first opportunity. And in this case, we're going to fix this code by saying catch the IO exception and then just throw the new framework exception. And by doing this, the things that call this don't have to declare that they're throwing exception. The exception is thrown right here. It's a runtime exception. It'll throw all the way back. And the nice thing about it is if you're using Spring, you could create a Spring exception handler. And the way you do that is you create a controller advice. You declare your class to be a controller advice. It also needs to be a component, which is not shown here, but it has to say at component or at service or something to show that Spring is managing it. And then you create an exception handler. You annotate it with an exception handler, and you pass in the name of the exception. We just defined the framework exception. So anytime a framework exception is thrown in this application, it's going to automatically come right here. And then you pass in the name of the exception also in the method. So we annotate it with exception handler and we pass in framework exception in the method signature. And now this will always be called. Now in this case, this is a service. So it's going to return a response entity. And it's going to create a new response with the message and a status. And it's going to return that. And so you've just elegantly handled every possible exception that's thrown in your code. Okay, another thing is listen to your IDE. In this case, the IDE is telling us that you see how it's like written in a light gray font. So that's throwing us that this method doesn't need to be thrown at all. It's not thrown anywhere in the method itself, so there's no reason to declare it. This was probably some legacy code that used to throw a parse exception, and it no longer does. So there's no reason to throw it. So let's just bang, get rid of it. Okay. Another thing related to exceptions is how often have we seen this kind of thing? You have just a very long string of exceptions in the stack trace. And it's too much. Like I can't digest all of this information because, excuse me, I can't digest it because it's just too much. So wouldn't it be nice if you could just consolidate it down to the frames, the stack frames that we're interested in? So it's very easy to write a very simple class that will create these kind of consolidated stack traces. I've written a sample of this here, and you could download these slides after. But the point is that it looks at all of the stack trace elements, and we would include this in that exception handler that I wrote, so that it would just return that stack trace. So it goes through all the stack trace elements. In my case, if they have my name in them, which is like you can see that there are a lot of them with my name. Those are here. Then it will save those. Otherwise, it'll just ignore them and put a ... Okay, and then it adds those and it returns that as a string. By doing that, it just produces a very neat stack trace. That's something I like to do. So the general rules of exception handling: never throw exception or runtime exception, because by doing that, you don't know what the exception was. So throw a very specific exception, put a nice exception message in there, and then throw the framework exception, create a framework exception class in your code and throw it at the earliest possible opportunity and include very specific information about the exception. You can include the exception in the class as a cause, and that gives you a lot of information. Also, don't catch exception or runtime exception. If you have something like this, catch exception, you're catching every possible kind of exception there is, right? There could be a null pointer exception, things that should have been handled. You'll never know about it because you're catching it. So be very specific about the exceptions that you're catching. So in this case, you want to catch something like IO exception, or be very specific about the exceptions that you're catching. One trick I like to do is when I see something like this, I just erase one of the letters in here, and the IDE will show me in red everything that's throwing a specific exception, and then I could tell the IDE to just add those exceptions to my catch clauses. It's a nice little handy trick. Also, don't do eprint stack trace, right? We're using logging libraries, and we want the logging libraries to send things to Splunk or Elasticsearch or whatever we're using. So when you do eprint stack trace, it's not going to do that. What we want to do is log those errors exactly using a logging library. While we're on the subject of Spring, I see this so often. People want to get their applications to work, so they go in and they modify their application properties, and by doing that, they'll forget and they'll commit that, and all of a sudden you have personal changes in your application properties committed to your Git repo. So that's a problem. The better idea is just create a local application, local properties, and add that to your profile. So just say Spring profile active equals local, or add it local to your Spring active profiles, and that will automatically override any of the properties that you need using your local. And that will never get to prod, because even if it does, your prod doesn't have an active local profile. Okay, another thing that's a really handy thing that I like to put in all my code, and I see people, never saw this before, but there's something called the Git commit ID plugin. And what the Git commit ID plugin does is it automatically reads all the Git information about your commit, and it creates a file called git.properties, in which you can then create an endpoint that will return all of the information in that file, and that's exactly what we're doing here. We've created an endpoint called git properties. Okay, I'm running it on my local host, but this can be deployed to any production environment. And look at all the information that it's returning here. It's telling me the Git commit ID. It's telling me the branch. It's telling me the commit message. So like all of this really important information. And in order to do that, all you have to do is use the Git commit ID plugin in your Maven, or corresponding in your Gradle build. And I'm tying this to the verify phase, to the verify phase, and that will, by saying configuration generate Git properties file, this will automatically generate a Git properties file. So this is very convenient when you're building your applications to include that. And then you create an endpoint that will return those properties. I call it the Git properties endpoint, and I return a response entity. And over here, I'm just reading that Git properties file, right? It automatically puts it in the target classes directory. So it's available I just say get class loader, which reads resource files, and I have the Git properties as a resource file. I just read it in, I say load, it loads it as a properties, and then I just return it as a response entity. And so I'm able to get something like this, which is really convenient. On a related note, while we're talking about plugins, so somebody asked if you could put the Git info into Actuator, and yeah, then you could also get certain information from Actuator. But if you want to get really granular information about your build, you get that by doing this plugin. On a related note, there's I'm sorry, on the subject of Maven plugins, there's a generate library sources in Maven plugin. So the idea of this is a lot of times you have library code, and Spring and people like that are really good about this. But a lot of times if you have internal library code in your own enterprise, you'll go and you'll debug something, and you want to debug into the library code. And the IDE is really nice about debugging, about decompiling your code, but decompiled code is not very easy to work with. So you can just add this little plugin to your Maven repo, and everybody who uses your library will be able to see the code. What it does is you add this plugin to the library repo, and it will generate 2 jars in your target directory, and it'll put those in your repo, whether you're using Artifactory or Nexus. It will store that in your repo, and all the IDEs are smart enough to look for the source snap. It's the same name as the jar, except it has sources appended to it, and the IDEs are smart enough to look at the sources. And so instead of decompiling the code, it'll actually display the source code. Okay, and just to show you a difference, on the left side, this is a decompiled version of some library code. So you can see it's very sparse. There's no comments. The variable names are very, right, the variable names are not part of the bytecode generally. So the decompiler just invents some variable names, and they're not very meaningful. This is the exact corresponding code from the source. So this was the source code, and this was the decompiled code. And you see how much more helpful and how much more meaningful this code is. So just by including that in your library, you're helping everybody who's going to use that code. Okay, so coding best practices. I see a lot of times people do this kind of things: array list, my list equals new array list. We should be coding to interfaces. So instead, we should be saying list, my list, right? We should never leave empty catch blocks. We should always document, add Java doc and inline documentation. One thing I like to do is when I'm writing code, I write it in pseudocode, and then I take that pseudocode and I build classes around that. And then I could change those pseudocode. I could either leave them in as comments or make the code self-documenting by creating methods that implement that pseudocode. This one, I like to use Project Lombok. A lot of people will probably walk out of this presentation when I say that, but it's really good for certain things. And especially if you're in an enterprise with a consistent build environment, it's very helpful for not having to code all your getters and setters and loggers and constructors and everything. You just use Project Lombok. You annotate something as a getter or setter or a logger, and it automatically creates all of the boilerplate code for you. So I like to do that. One thing I see a lot of people are still using try catch box with a finally, where they close the stream. Instead, we should be using try with resources, right, for auto-closable resources. And this one is really, it really bugs me, is code is not complete until the tests are written. So looking through code and looking at code, doing code reviews, there's, wait, before I get to that, somebody pointed out that Java records make it easier to avoid Lombok. That is true. If you can create records, they're final. If you could live with that, of course, they're preferred to Lombok, but in many cases, we can't use records. And also Lombok provides a lot more capabilities than just what you can get with records, logging and things like that. So back to testing. So code is not complete until the tests are written. In IntelliJ, there's a really nice plugin. I haven't seen if it's in Eclipse or not. I believe it is, but it's called the Test Me plugin. And what it does is you just click on code, or you could click on generate, and there's a Test Me icon. You could download this from the IntelliJ market. And what the Test Me plugin does is you could just right click on your code and you pick the test that you want. So in my case, we were using JUnit 5 and Mockito, and you could generate a whole suite of unit tests for your code. So these are not going to be finished tests, but what they are is almost finished tests. They generate all of the scaffolding that you need. And then you could go in and you could run these tests as is, and they'll generally work. Or you could go in and fill them in to make them meaningful. And that's what I like to do. And you'll get really good code coverage for very little effort. So I encourage people to use that. And for God's sake, don't just commit your code and say I'm done. Always try to create a unit test as soon as your code is as soon as you finish something or you made a change, and run the tests and make sure that they still work, that you didn't break anything. It's a good idea also to break something and make sure that your test fails, because if a test tests something and it doesn't actually fail when things break, then it's not a very good test. Another, this is an IntelliJ trick I really like. A lot of times we build things that we don't really want to commit. And so I've created all these little studies. I certainly don't want to commit them. I created these studies just to learn a little bit how something would work or prove something would work. So what I do is IntelliJ lets you create it lets you create a change list or a set of change lists. And then, so in my case, I create a change list called don't commit. And my regular changes I check, which means they're going to be committed. And the don't commit changes, I just don't check. And so these will never get committed to they'll never get like accidentally committed to your code, to your Git repo. So it's just a convenient thing to prevent you from making mistakes. While we're on the subject of IntelliJ, I would say learn to use IntelliJ advanced features. So IntelliJ is nice enough to give you this little red, amber, green symbol, and you just could hit F2 or hit these down arrows, and it takes you down to the next error, the next error, the next warning, and it helps you, you go and you correct it. And then, hopefully you're going to get to a green state by applying all of those. Another thing, when I'm doing Java interviews, when I'm interviewing candidates, one of the first things I ask them is, do you use the refactor menu, right? Eclipse has a refactor menu, IntelliJ has it. These are really important. And they give you the ability to extract duplicate code, and renaming things, and just inlining. If you have lambdas that you have a body, it allows you to inline it right away. It'll switch statements. So I ask people about this. If they are not using the refactor menu, they're probably not writing really good code, and there's a very good chance that they're not going to get the job. Also, the version control support. Everybody likes to use, but I think we're pretty much all familiar with Git, and so we do, Git branch and Git commit and stuff. But the IDEs all provide really, really solid Git support. If you're using Git, really any version control is supported within the IDE. And it's really helpful. And one of the things I really like is the diff view menu. So you can diff your current code with previous code. You can make changes right in the editor library, editor window. But one of the things I really like is diff with clipboard. So I could copy some code from anywhere, and then I could right click on the IDE and I say diff with clipboard, and it'll show me changes that were made. So I could go to like a previous version that wasn't in version control or something, and I could diff it with the editor window and get a really nice quick diff view, where I could edit right in that window. Okay, and somebody pointed out, Srish pointed out that you could always learn new features by following the IntelliJ hints and warnings, and that's really true. I've spoken to people, and they say, oh, I turned that off. I don't turn those off. I really read them, and I try to learn them, and I try to get used to them, just get my fingers in practice with whatever IDE or whatever application I'm using, whether it's Java IDE or Edge or Chrome. It's good to learn the keyboard shortcuts, so it makes you really productive. Also, there are a lot of things in the IDE that are built in, like column mode. I love column mode. You could control down arrow. Now, I don't remember these things, but my finger remembers them. So you could control down arrow, and it will automatically put you in column mode. And you can make a common change. Like, let's say you want to delete all of the, you want to change something in the first line of a whole set of lines of code. So you can just select that column and make the change. You can copy and paste into there, and it'll change it in all of those corresponding columns. So it's a really convenient way to make quick changes. Also, there's scratch files, right? You can create a scratch file that won't ever be part of your project, but it allows you to format things like apply formatting to strings that you might have in XML or JSON, or Java. So it's really convenient to learn these things. Another thing is learning key map shortcuts. So my favorite shortcut in IntelliJ, and I mean, these are just IntelliJ ones that I use every day. But one thing I like to do is ask people, what am I doing wrong? And I'll do a selection in IntelliJ. And I'll, click and draw and drag and make a selection. And there's no reason to do that, because if you just do Control C on a line, it will automatically copy that whole line to the clipboard. And there's no reason to select it first. It'll just copy the whole line. The same thing with Control X. If I do Control X, it'll just copy the whole line. It'll just copy the whole, cut the whole line. So it'll delete it. It's really nice. You don't have to do the selection. So it makes you really productive. I could do F2, which will take me to the next error. I could do, there's so many different shortcuts that are really important. Sometimes you see all of the imports in your IntelliJ project. All you'd have to do is Control Shift minus and then Control Shift plus, and it will close all of those imports. So, you're usually not interested in seeing your imports, and it'll take you right to your code. Control W. Boy, do I have a good project open? I should let's see. Just bring this up. If I do Control, let me bring it up in window. I could do Control W, and it will automatically select more and more code. So it automatically increases, it expands the scope. You see now it's selecting the whole if statement. Now it's the whole else, if and else. And then if I put my finger on Shift and Control W, it goes in the reverse direction. So it remembers where I am. And just while I'm at it, see the import statements is what I was showing you about Control minus. We'll shrink everything, and then you do Control plus, and it brings it back, except for the imports. If I do Control plus again, it'll bring back the imports. If I want to see errors, I could do F2. There are no errors in this file, thankfully, but if there were, it would bring me to the next one. So many things like that, and it's really worth learning how to use shortcuts. One way to learn it is, let's say I know that I want to do something, right? I know I want to build my project. So I'm going to go up here and I'm going to say build project. But I notice on the right, it tells me what the shortcut is, right? This is an IntelliJ shortcut. Eclipse does the same thing if you're using Eclipse. So instead of clicking here, the lazy way, I'm going to exit there and I'm just going to remember that Control F9 is the way to build a project. So I'll do Control F9 and the project will build. And by doing that, I'm training my fingers to learn what the shortcuts are. So again, I look at the shortcut, I exit out, and then I click the shortcut. And so that I'm training my fingers to learn how to use those shortcuts. So many others. People, when you go on a Java interview, the first thing they do is they put you in front of a hacker rank screen. I hate hacker rank because let's say I'm interviewing a carpenter for a carpentry job. I don't want to give him fake tools to work with. I want to give him I want to let him use his real tools or her and see how they use the tools. Have they mastered their tools? Do they know what they're doing? By giving somebody hacker rank, you're learning that they know how to use algorithms and they studied algorithms, but I really would rather see them use the IDE that they were. So when I do a Java interview, I tell people in advance, bring your favorite IDE and we're going to do a screen share and you're going to show me how you're going to share some code. Okay. Other IntelliJ features, and these are actually not necessarily IntelliJ features, but Java features. So there's hot swap. A lot of times you make changes in your code and you think that you have to restart the application, and sometimes restarting that application can be really slow. So what I recommend instead is to just recompile rebuild that class. If you've made small changes that like you haven't changed method signatures and you haven't changed the method, the class structure, all you have to do is recompile that class and not restart the application. Okay, another thing is micrometer tracing. Now, if you want to get an extra bonus this year, I recommend learning about micrometer tracing. It's really simple and it really adds a lot of bang for your buck. What is it? First of all, it's critical for problem resolution. What it does, it injects a trace ID into every incoming and outgoing request, and it automatically logs the trace ID in every log message. So all you have to do is just add the micrometer tracing dependency, and you have to add actuator, and automatically that will add. Also, you have to specify a logging pattern either in your logging properties or in your Spring config. If you're using Spring, you can put it in the Spring config. If you're not, you could just put it in the logging.properties file, and you set a logging pattern, and that will always include the trace ID. In this case, the pattern is displaying a logging level like info or debug or warn or whatever. It will also insert the trace ID, and this is telling your logger to always insert the trace ID in this position. And then it will also print the span ID or whatever other things that you need besides your log message. Excuse me. What that does is, in this case, you could see we have. In this case, we're calling Session Keeper API, right? That's one service. Let's say it's a microservice, and we see that it's using a certain logging. It's using a certain trace ID, right? And then I have another service called Authorization Manager. You notice it's using the same trace ID. These are all calling each other, and they're even going through a gateway, but they're all preserving the same tracing ID. And that's something that Micrometer gives you for free. I happened to be talking to one of the founders of Micrometer the other day, and I asked him a very poignant question. I asked him, how do you pronounce it? Is it micrometer, like everybody keeps pronouncing it, or is it micrometer? And he said, very frankly, I don't know, but I use the word micrometer. So I was using micrometer before, but now I switched to using micrometer. Okay, and you see that micrometer preserves the same trace ID. So now I could go into, in this case, I'm using Splunk. I could go in and put that trace ID into my Splunk search, and it will display all messages that contain that trace ID. So I'll tell you, when I was a kid, I remember I went to Berkeley to visit a friend of mine, Berkeley College. And there was a guy named Swami there. He wasn't a student, but he was a very interesting fellow. He would take a soapbox and stand on it in the quad, and he'd just start talking. There was nobody there to listen. And like, sure enough, people would start gathering. A person would come here, and before you know it, there was like 10 or 15 people listening to Swami. So I'm going to stand on my soapbox, and I'm going to give you some tips that I found in my travels. So we have to remember that code, we have a tendency to write code, and it works, and we move on. But you're not done. You have to write code that's readable. You're going to come back to this code in 2 weeks, and you're not going to remember what you did. And certainly somebody else who's coming in is not necessarily going to understand what the code is. So comment your code, don't duplicate your code. Just try to write code that's going to be maintainable in the future by you and by other people. Follow the dry principle. Don't repeat yourself. Refactor. Use the refactor menu to eliminate redundancy. You can select a line of a block of code, and you could refactor it into a method, and the IDE will be smart enough to look for that pattern in other areas of your code and offer you opportunities to inject that new method that you've just extracted into other areas of your code. And so that comes through always refactor when possible. You should have good unit tests, continually improve your code quality. The IDEs are all very reliable nowadays, so they will do the refactoring for you without introducing new bugs. Always add comments. You don't want to add comments on every line, but do add comments to explain why, not what. Let the code explain itself where possible. Use method names that explain what you're doing. And come back to the code a day later and try to understand it. And if you can't, add a comment, rename a method, add documentation. As I said before, always test early, test often, write unit tests that break, then put in an implementation and make sure that unit test passes. When you make a change, write a test. Do code reviews with committers. I remember I was once talking to an agile specialist, and he told an interesting story. He said that he was coming in to do a consulting session with an enterprise, and he recommended doing pair programming. And the firm they were pushing back, and they were saying, I'd rather have 2 developers working on 2 pieces of code rather than 2 people working on the same piece of code. And so he said he captured a metric. What did he do? He walked around and he looked at how many people were coding in the shop. And how did he know what they were coding? He said, I defined coding as they had a keyboard open and their hands were reasonably close to the keyboard. And he said, I noticed that when I walked around, 20% of the people were coding. When you do pair programming, he said 80%, there was an 80% coding average. So he proved that pair programming was actually way more efficient than individual coding. Again, code for maintainability, write code that you or future versions of yourself or your other people on your team are going to understand. Come back to the code a day later, add comments. As I said before, handle errors properly, implement error handling and logging. Use our trick about creating an exception handler, and return meaningful error codes to your users so they know exactly where the error happened and how they can fix it. And finally, keep learning, keep evolving. The other day I went to the doctor, and I told her that I was a computer programmer, and she was like, wow. And I was like, you're a doctor. You have to keep up with the changes. And she said, no, the changes in the computer industry and technology are so much faster. I really respect that. So yeah. And finally, don't be cavemen like these guys. You know, there's a lot to learn. Don't just say we're too busy. Go and take the time to learn it. And that is my soapbox. Thank you, everybody.
Thank you so much, Victor. That was an amazing presentation. It was so refreshing, and I just loved all the reminders and also the takeaways. Yeah, I definitely learned like 2 or 3 things that I need to go and immediately start using, or learning how to do them as well. So thank you. It was a beautiful presentation.
Thank you, Srisha. And I just encourage everybody, like, keep coming to these things. Keep, the Pittsburgh group. I encourage people to actually join physically and join other presentations as well. There's so much good stuff.
Yeah.
Thanks, everyone. Any questions?
I really love some of your comments on the peer programming and peer reviewing with people, because I mean, it really works, and many people still don't see how much value that can add at the end of the day, because the quality is higher. You have better relations with your team, and it's not just actual code quality. It's you building your team to be more cooperative with each other.
Yeah.
It's really true. And sometimes you can even you could do pair programming with junior programmers, and they'll see things that you didn't see, and you're teaching them at the same time. So it's important.
Yeah, and readability is very important too, because code does get read more often, and it's always very funny whenever someone has a moment where they're like, "Who wrote this?" and they look at the Git blame and it was them like 3 or 4 years ago, and you're like, "Gotcha."
Yeah.
True statement.
Yeah.
Okay.
Yeah, thank you. Thanks a lot, Victor. I mean, if there are any questions, like, ask us on the chat and we can ask on your behalf. And I know Victor was also reading throughout the chat, like, even the chat was going on. Victor, we had a good time in this presentation. I think it was great. Yeah.
Thank you. Thanks, Srisha. Thanks for inviting me.
Oh yeah, absolutely. So if no one has any questions, we can wrap up, and we made like good time at 6:50. I think we can all go back to our Thursday evenings, and Renat will do the magic and upload it on YouTube soon, right?
Yeah, probably within the week. But yeah,
Okay. Yeah.
I'll make sure to cut it and upload it within the week.
Okay, yeah. And also, Victor, like, are these slides available somewhere for you to share? I mean, if you do, we can add it as a comment on the meetup invite itself. Otherwise, we could. I mean, I can share it with the attendees in a different format. Yeah.
Yeah, I'll touch base with you after, and I'll upload
Yeah,
it.
we can figure out a way. Yeah, we can do
Okay.
that. Okay.
Awesome.
Yeah.
Yeah, and we can
Sound-
also share them on the video too, on like
Yeah,
YouTube.
that's true. Yeah, we actually put it on the YouTube description, the
Ah,
slides as well. So we
perfect.
can do that at that point. Yeah. Okay, dokes. Cool. Thanks a lot, everyone. Thank you, and have a great evening and also the weekend. Yeah.
Thanks, everyone.
Have a good one. Bye.